Katrina Emery from one of our 10 NASA centers across the country. Let me pull up your official name and title here for everybody. Katrina Emery from NASA's Dryden Flight Research Center. Katrina, we are happy to have you here today.
Oh, I'm thrilled to be here.
And Katrina, you have an exciting program to tell us about today, don't you?
I do. It's one of our Office of Education programs called the University Research Centers. And the University Research Centers are at our nation's historically black colleges and universities, Hispanic serving institutions across the nation. We currently have 13 funded URCs, and they're funded at $5 million. And so they're able to do awesome research on their campuses. And they have high student involvement. So we're looking for students who have excelled, taken those hard classes, and in science, technology, engineering, and mathematics. Today, we have a historically black college called Texas Southern University, and they are going to be flying an experiment on the space station. So
to the space station.
To the space.
I said the exact same thing earlier.
That's right. To the space station for the 11-day mission.
Correct, and that's exciting that they're going to be on the program here coming up in just a minute. So Katrina, there at Dryden, we're happy to have you here. I'm sure you've seen landings before out at Dryden.
Yes, I've seen a number of landings, but this is my very first.
That was going to be my question. This is your first launch.
Very first launch.
Well, hopefully it will happen right behind us. You can see the countdown clock. A little windy, but we haven't heard any bad news. We're in a 9-minute hold right now. And Katrina, thanks again for coming.
Thank you.
And hopefully we will have a launch for you here in just a minute. In fact, for everyone else, I'm going to go ahead and show you some of the activities going on here on NASA TV. Let's check in with them real quick. Our university here today, and we are excited, first of all, to have the president of Texas Southern University, Mr. John M. Rudley. And thanks for joining us today, sir. So, Mr. Rudley, tell us all about Texas Southern.
Well, it's my honor to be here, and NASA should be commended for reaching out to Texas Southern University. We know the Office of Education has done a lot of work, as Katrina has mentioned, try to get black colleges involved with NASA and research. So we want to thank them for providing our partners this opportunity. We also have wonderful students and faculty. So the fact that we are flying on this space shuttle is an indication that our research is going to be one of our focuses in the next 5 to 10 years. We'll make sure we're one of the best research institutions and high colleges.
Well, great. So we're excited to have you here, and you have brought some of your students with you here today, and we're going to be bringing some of them on camera here in just a second. Mr. Rudley, have you ever seen a launch before?
I haven't seen a launch before. Sorry.
Okay, well, hopefully we'll have one for you right behind us here in just a few minutes.
I'd like to say one other thing, too. With our project, we are reaching out to 16 high schools in the Houston area, and we're partnering with them. So we're trying to encourage more students in the inner city areas to be involved with academic programs to lead to science, technology, engineering, and math graduates. So this is part of our effort with NASA and the university to try to reach out to these 16 students. So for anyone that's listening, make sure you understand that science, technology, engineering, math is still alive, and Texas Southern's in the middle of it.
That's right, and if anyone is watching and listening, you can actually go ahead and email questions live to us at nasalearn@gmail.com. That's what I have up there, and we will take as many of those as we have. We've already got several questions that have come in to us here on the email coming through my iPhone here. And Mr. Rudley, let's take a look at some of the goings-on behind us. This is now a live shot out at Launch Pad 39A in the Space Shuttle Atlantis. Good time with Sharita Thomas. Sharita Thomas is a PhD student from Texas Southern University. Excited to be here for the launch, and she's having such a good time that we're up here laughing. Sharita, why don't you tell us what you know about this experiment?
Well, Texas Southern established the Center for Bionanotechnology and Environmental Research as part of a NASA URC, and students involved in CBER, and the CBER for short, developed the URC Microbial 1 experiment. And basically the purpose of this experiment is to evaluate morphological changes and molecular changes to bacteria as a result of their exposure to the space environment. So this is important because Bacteria are essentially hitchhikers on the ride along with the astronauts on these human space exploration missions. So it's important to understand how they adapt to the space environment. And this will give us information as to how microorganisms that pose a threat to us, to human health, would act as a result of similar exposures.
Okay, great. So that experiment will be on the shuttle, hopefully be launching live here in about 45 minutes or so. And this is indeed going to be your first launch too?
It is my first launch, and I'm so very excited.
We're glad that you're here for the launch. Glad to be partnering with you. Good luck on your PhD.
Thank you so very much.
I keep threatening to begin my program. So, Sharina, let's take a look at this image we're going to bring up now. This is actually, once again, live Spatial Atlantis at Launchpad 39A, preparing for launch. Good job.
Thank you.
Okay, now we'll bring this back here in just a second. Abogunde. My job's too fun. I'm paid to do this. All right. Okay, I'm back now with another person from Texas Southern. This is MS student Nene Abogunde. And you were going to tell us a little bit more about this thing that's flying on the space shuttle today.
Yes, I am. So we are doing an experiment that looks at the structural changes or morphological changes and the molecular changes in bacteria. This experiment involved, there are 3 parts to it. The first part was to look at the preliminary optimization, which is basically just early experiment done at Texas Southern University. We looked at the best temperature, the best number of cells, and the best medium to grow this bacteria and prepare it for flight, which leads us to the second part of the experiment, which is a flight experiment. And that involved the loading and packaging of this bacteria with the appropriate medium.
We are live. We have bees flying around.
And packaging this bacteria and the medium into hardwares, 2 of which are the fluid processing apparatus and the gaps, which are also known as the group activation packs. These hardwares basically just are chambers whereby we load the medium for the bacteria and the bacteria, and we fly them to space. Then the third part of the experiment is the ground control experiment, which is done here at Kennedy Space Center, just like the flight experiment, and similar to flight experiment but done on the ground. And overall, it was exciting. I got to, for the first time, and of course, be part of the first flight experiment for Texas Southern University, yay! And also being here to work at Kennedy Space Center, it basically helped me build my skills, my scientific skills, my space science, explore space science even more, which actually helped me pursue my own career goals as being a scientist in the future. Overall, I'd like to acknowledge my mentor, Dr. Rosenzweig, my partner Kelsey Parks, Dr. Cohen, and Dr. Dojoloa, and it was a nice experience. And I'm looking forward to other children in the future participate in science like this, and also be able to build your own career path and your science background. If you want to know more about this experiment, you can visit our website at www.cber.tsu.edu. Thank you.
Nice job today. Thanks for having us. Now, what we're going to do is I want you to see the monitor because we're going to look out the launch pad again. Now, this time I'm going to maybe try to pick up a little bit of audio that's coming from out there and see what they're talking about. Okay, you're off the hook. You're going to do your thing. Sayo, Jalawa. Is that close?
Yes.
Close enough?
Very close.
Close enough?
Yes.
Close enough for government work? Okay. And we are going to get you queued up in a second. You're the principal investigator.
Yes.
That Okay, we are back here, and I now have the principal investigator for this project, Fasayo Chijelua, and you're going to tell us even more about this. Since you're the PI, you should know just about everything.
Okay, and to all of the kids out there in Houston and other cities listening to us, welcome. And please, we want to invite you to visit our website at cva.tsu.edu/3611. The samples from the experiment will be coming back. They're not coming back live. They will be fixed, and this will be available for you if you want to look at the structure and the morphology post-flight. Also, beginning tonight, we would have information on the synchronous ground experiments available to all of you. We engage in this because earthbound microbes, we know they have beneficial and non-beneficial effects. However, in space, we have no idea how microorganisms will behave. And for us at Texas Southern University, it is a wonderful opportunity that NASA has given us to be able to join the few elites that are studying space microbiology. This is raising the level of research at Texas Southern University, and we are elated and we are excited and proud of our students. The experiment is using two microbes, E. coli, a gram-negative bacteria, and Bacillus subtilis, a gram-positive bacteria. And we are studying the growth and morphology of the organisms on the space shuttle at Atlantis while it is docked to the ISS. And when we bring them back, we are doing molecular analysis to see the effect of space environments such as microgravity and radiation on the biologically important molecules. So overall, we will study how space affects the structure, morphology, and molecular biology. The second main goal for us is just to reach out to the kids out there. According to the latest National Science Foundation statistics, which came out in October, the number of African American students declaring STEM majors is declining and has been declining for the last 4 years. And this opportunity affords TSU the opportunity to reach out to the K-12 community out there, especially from these members that are underrepresented in STEM fields. And we want you to get excited to join us and begin thinking of developing technologies that I can't even imagine today. And to the K-12 community out there, we are saying that the future is a wonderful place to be, and we at Texas Southern are ready to travel that journey with you. So.
Way to bring it home there, and hopefully we will have a launch for you coming up. Fasayo, thanks for showing up today, and I'm happy to see that you're interested in STEM education for all levels of students, and I think this is really good what you're doing, making those experiments available to students post-flight. That's pretty cool. And go ahead, I'm sorry.
So we will make them available to students and make the experimental steps available so that you can repeat it, and then you can do your counter experiments and ask questions. And on behalf of Texas Southern University, I just want to acknowledge and thank NASA, BioSAF for providing the hardware, and I congratulate all of the SIVA faculty, students, and laboratories out there. Today is your day, and I say to Atlantis, go Texas Southern, go Tigers, and congratulations to all.
All right, well put. Let's take a look out there at the launch pad. Hopefully we'll have something for you here in just a little while. You are off the hook. Good job.